In this lab, we will continue with the data set we imported for the causal analysis. So in step 1, we did the exploratory data analysis. We cleaned the data and we prepared it for doing the causal analysis. We made sure that most of the variables are numeric variables in the data set. Step 2, causal inference using propensity score matching. Propensity score matching, or PSM for short, is a widely used technique in causal analysis, causal inference. It aims to estimate the causal effect of a treatment or intervention on an outcome variable in observational studies. The core idea behind propensity score matching is to balance the covariates between treated and control groups, making them more comparable. We'll implement propensity score matching manually using a scalar and pandas modules. Causal inference problem. We are interested in how much a personal experience has a crime victim, exp crime, that's the column name, would make them worry about it, that is worry crime. We'll perform propensity score matching for this purpose in general. Process both worry crime and exp crime into binary. So binary is either 1 or 0. There are two choices. Logistic regression for propensity score matching. Target variable, X prime, covariates are the relevant covariates. Propensity score matching. Use the estimated propensity scores to match treated and control units. Assess balance. Check if the covariates are balanced after matching. Causal effect estimation. Use worry crime as the outcome variable to compare outcomes between treated and control groups. Exact steps in propensity score matching. Number 1. Survey data that have already been collected: age, gender, income, country, and so on. These are covariates. Often our covariates are potential confounders that could bias our results. The intervention equal binary, yes or no, and follow up on our outcome equal another binary, yes and no. So the covariates and the outcome are both in binary numbers. Let df underscore psm equal df.copy open and close bracket. Printing df copy, it gives us these values. There are 120,680 data rows and 61 columns. Let's look at df-psm of exp crime. So it's of float 64 type. df-psm, we will subset the exp crime for more than 0. So df-psm bracket, square bracket, df-psm of exp crime greater than 0 and we will look at the column X crime and we will do value underscore counts open and close bracket. In case if we don't do, then it will print all the data, column values. Now when we do X crime in bracket, then it prints only the X crime column. And when we do the value counts, so for greater than X crime greater than 0, there is only one value, 1, and it is 25,066 in counts. Let threshold equal 0. Treatment variable df of PSM of X crime, let it equal to df of PSM X crime greater than threshold. Threshold is 0, greater than 0. And dot S type int. So printing df of PSM X crime gives us. Now what we are doing is I'll just create one more cell above, and let's look at df of PSM of X crime. So these are the values, and when we do greater than 0, it gives us false and true values, and then we'll put this in bracket and we'll do dot S type of int. So this will change the false and true to int. The false is 0 and true is 1. Printing df of PSM, df PSM of X prime gives us these values. Let's print a df PSM of worry crime. Outcome variable. So the treatment variable is X crime more than 0, and outcome variable is worry crime more than 0. So this changes that those two columns into binary digit. So I'll just show that. So df of PSM worry crime looks like this, and greater than 0 gives us true and false. Now if I do if I put that in bracket dot S type int, then this will convert true to 1 and false to 0. So that changes the column into binary column. Now df PSM dot worry crime dot value counts contains 1 80,053 in count and 40,627 values of 0. Then step 2, we calculate propensity scores. The propensity score is the probability of receiving the treatment given the covariates. We will perform a classification model to estimate the probability for a person to belong to one of the two classes. Experienced crime has a victim, so that's the column X crime, that's experienced crime, equal to 1. Has not experienced crime before, that's S crime equals 0. Hence, for this model, the target variable would be the treatment variable X crime, However, note that ultimately we are interested in knowing the impacts of the outcome variable, worry crime. The list of covariates should not include the outcome variable itself. Including the outcome variable in the list of covariates can lead to problems like multicollinearity and secular reasoning. We'll implement a simple logistic regression for this purpose. From sklearn.linear_model, import logistic regression. Length of dfpsm dot columns is 61. So there are 61 columns. We can only take numeric variables for modeling. Let's adapt the code to define covariates so that we only take numeric variables, then implement the logistic regression model. So the logistic regression model is built for the numeric variables. Define the covariates including S crime, experienced crime, and worry crime. So let me put another column, another cell above. Okay, dfpsm dot select underscore data types bracket include equal number. So this will include all the values that are of numeric type, and we want the columns, and these are the column names which are numeric. So let covariates equal array of call for call in dfpsm dot select underscore data types d types bracket include equal square bracket number close the bracket dot columns if call not in X crime and worry crime. So we don't want to select experienced crime and worry crime for covariates. We want to select the rest of the numeric variables. And length of covariates is 58. Now checking DFPSM columns. The country, you can see that it is not included because the country is of categorical type. Fit a logistic regression model to predict treatment assignment. Let LR model equal logistic regression opening close bracket. LR model dot fit of DFPSM of covariates so DFPSM of covariates so let me see what covariates are. We need to run this again. Then we run the covariates. So these are all the columns. And df of PSM covariates gives us all these values. Okay, so df of PSM covariates. So LR model dot fit bracket df PSM of covariates. These are all the numeric columns, comma df PSM DFPSM of experienced crime. So let's fit this logistic regression. So it gives us some warning messages. Convergence warnings. IBFGS failed to converge. Status equal 1. Stop. Total number of iterations reached the limit. Increase the number of iterations. The maximum underscore iter or scale the data as shown in scikit-learn. So maximum iteration has been reached and we need to increase the limit of the maximum iteration. LR model dot predict underscore proba of DF PSM of covariates. So covariates are the array of all the numeric variables. And when we run that, we get this. So these are the predictions, the probability predictions from the linear model. Get propensity scores. Let DFPSM of propensity score, so this is a new column created in DFPSM, equal LR model dot predict underscore proba of DSM PSM of array covariates. So DFPSM of covariates looks like this. And when we do LR model predict underscore proba of DFPSM of covariates, then it gives us this, and we want to take the all the row values by putting the colon, comma, and then 1. We don't want the first value, we want the second value. And this will be the array of all the second values from the predict proba. So the new column propensity score in the data frame DFPSM will contain this array of the values. The warning message we are seeing indicates that the logistic regression model did not converge, meaning it did not find the optimal solution within the specified number of iterations. This can happen if the data is not well scaled or if there are issues with multicollinearity. Here are a few steps we can take to address this issue. Scale the data. Logistic regression is sensitive to the scale of the features, so standardizing them, example using standard scaler from scikit-learn, might help. Increase maximum iterations, that is max underscore iter. Increase the maximum number of iterations allowed for the model to converge. You can do this when initializing the logistic regression model. Let LR model equal logistic regression of max underscore iter equal 1000. That is to increase the number of iterations. Check for multicollinearity. Multicollinearity occurs when predictor variables in a regression model are correlated. This can lead to convergence issues. Check for separation. Logistic regression can fail to converge if there's complete separation in the data, meaning one of the classes can be perfectly predicted by a linear combination of the predictors. This can be addressed using techniques like Firth's penalized likelihood or adding a small constant to the diagonal of the covariance matrix. Try different solvers. You can also try different solvers for logistic regression. For example, let LR model equal logistic regression of bracket solver equal lib linear, comma max underscore ita equal 1000. Some solvers may be more suitable for certain types of data. Reduce the number of features. If you have a large number of features, it might be worth considering feature selection or dimensionality reduction techniques to reduce the complexity of the model. Right. We also forgot that we'll need to implement all the data processing step before modeling. Let's try the first two as we can easily do them. The first two are scaling the data and increasing max underscore ita. So for scaling, we'll from scalan dot preprocessing import robust scalar. Initialize the standard scalar. Let scalar equal robust scalar. Open and close bracket. Printing the scalar gives us this. So scalar is the robust scalar. Now create a copy of the data frame. Let df scaled equal df_psm dot copy, open and close bracket. So df scaled is the exact copy of the df_psm. Now scalar.fit underscore transform of df_psm of array of covariates. And covariates is the array of all those columns which are numeric. Fit and transform the data. df scaled of array of covariates, let it equal to scalar.fit underscore transform of df_psm of bracket array of covariates, printing df scaled. So all these values are now scaled, standardized by robust scalar. Fit a logistic regression model to predict treatment assignment. Let LR model equal logistic regression of max underscore ita equal 1000. This is to increase the number of iterations. LR model dot fit of df scaled of covariates. Covariates is the array of numeric columns, comma df scaled of exp crime. We no more get the convergence error. Get propensity scores. df scaled of propensity score. So this is the new column that we are creating in the df scaled data frame, equal LR model dot predict underscore proba of df scale of square bracket covariates, and covariates is the array of numeric column values, and bracket colon comma 1. So I'll just show that. So df scaled of array of numeric columns, it looks like this. Then we'll use the a logistic regression model, LR underscore model, to predict probability, predict proba of these data frame. And it looks like this, and we will select from here, we'll select all the rows, so we will put the column sign, and we will put 1 because we want to select all the second values, and it is the array of the second values. So the propensity scores are these, and it is placed in the end of the data frame as a new column. Great. We can now proceed to the next step of propensity score matching. Okay, we will continue in the next lab.